and I have current leaving this terminal, flowing through the circuit into this end of this double wire. So part of the current will go through this orange wire, and part of the current will go through this orange wire. So I have a current in this wire at the same time I have a current in this wire, and then it gets together again and goes back around through the circuit. Notice that there's a small gap between these two wires, and when I throw the switch, watch what happens to that gap. The wires get pulled together, and that happens when we have parallel wires with currents each in the same direction, or that is, current in each wire in the same direction. Try that one more time. The two wires come together. Now, if we turn that around so that we have the current in one wire going one direction, the current in the other wire going the other direction, we'll see the opposite effect. We'll see the two wires repel one another. Now I have the circuit set up so we have the current coming out of this terminal of the battery, going down through this wire and back in the opposite direction and back around through the circuit when I throw the switch. So now when I throw the switch, we'll have the current in one wire going in one direction, current in the other wire going in the opposite direction. Still have two parallel wires, but notice what happens now to these two wires when I throw the switch. They now separate, showing that when the currents are in opposite directions in two parallel wires, there's a force of repulsion between the two wires. We can understand that in terms of the nature of the magnetic force and also the magnetic field. A charged particle moving through a magnetic field will experience a magnetic force. We can think of one of these wires as being the source of the magnetic field, and the other wire having charged particles moving through that magnetic field experiencing a magnetic force. But of course, Newton's third law always applies. We can also think of the other wire as creating a magnetic field because there's current moving in it, and the other wire, the original wire, then will have a current flowing through a magnetic field experiencing a magnetic force. So the magnetic force between two wires is due to the magnetic field created by one wire and the current in the other wire moving through that magnetic field experiencing that magnetic force. Moving charges in a magnetic field